So in this video, I'm going to continue talking about general wave characteristics, and I'm going to discuss interference, resonance, and Doppler effect. So interference is when two waves encounter one another, and when they encounter one another, their amplitudes or energies are going to affect one another. If two crests arrive at the same time, then those amplitudes are going to add. If two troughs arrive, or a trough and a crest arrive at the same time, then they're going to cancel out. So their energies are either going to add or cancel based on how they arrive. And the idea of their arriving in different orientations is called superposition. So the waves are actually overlapping one another as they encounter one another. So you see here, remember that waves are circular, so we see here a wave being emitted at this point and this point. And then as they come into contact with one another here, you can see that there's some interaction between the two waves where some is bright and some is dark. Okay, so this is the idea of wave interference. Now, there are two types of interference. There is constructive interference, and this is when the wave amplitudes actually add. So if we see two waves moving towards one another here, the yellow and the green, and as soon as they come in contact with one another and they're overlapping or at the same position, now we can see that the net wave that's going to appear is this red one here. And so you see here their amplitudes are adding. Here, when they're completely overlapped, we see a complete addition of the waves, and then they move along in their relative directions. Now, destructive interference is the opposite, so this is where they're actually going to cancel. So when they encounter each other, you see that the net wave is flat. And here, when they're completely overlapped, it flattens out, and then they move in the other direction. Now, let me quickly open up, and I can show you a simulation of this happening in real time. So the black demonstrates the net wave at every relative position between the two. So you see when the blue wave and the green wave are even here on the flat line, they're going to completely cancel out, and so the net would be destructive. And then when both of their crests are in line with one another, then they are constructive. So there's destructive and constructive. So constructive is when the crests are in line, and destructive is when a crest and a trough are in line. Now, we can generate waves like this called standing waves, which have a complete destructive and constructive interference along some controlled medium. So in air is the most common example, because this is actually how we generate notes in musical instruments. And when we trap this standing wave, the note, or whatever that frequency note, rings out. It actually resonates very loudly, and we'll talk about what resonance is here in a minute. But a standing wave is when we sort of trap this constructive and destructive interference, and we end up with nodes and antinodes. So nodes where you've got the destructive, and antinodes where you have the constructive interference happening. So resonance occurs as a result of sort of a mixture of the interference and the standing wave. So all objects are going to vibrate at a natural resonant frequency, it's called. So in a previous video, when I was talking about states of matter, we talked about how solid particles or solid matter has tiny little particles that are in a fixed position, but they're vibrating in place. And their vibration has a natural frequency to the vibration. So if I were to introduce a wave from an external source or bring it close to a solid object, and it had the same frequency, then there would be some interference and the amplitude would increase. Now, in class, we'll watch this video, or you can go watch it on your own. There's a bridge in Tacoma, Washington called the Tacoma Narrows Bridge, or also is nicknamed Galloping Gertie, which had a whole bunch of wind that flew down through this valley, and it was actually caused the bridge to resonate, and so it caused the bridge to gallop. And we'll watch that in class. You can watch it on your own to sort of get an idea. But another example of resonance that you might be a little bit more familiar with is the idea of an opera singer shattering like a crystal glass. So the crystal particles or the glass particles are vibrating at some frequency, and when the opera singer hits a note of the same frequency, then the amplitude increases of the particles, causing the glass to shatter. So this is another example of resonance. So resonance, the definition, is a force vibration that causes something to vibrate near an object, okay? And it's all based on the resonant frequency. Now the last property I'm going to talk about is the Doppler effect, and I'll go more into detail about Doppler effect in both sound and light, as I will with all the other wave properties. So the Doppler effect is the idea that when an object that is emitting a sound is moving towards or away from an observer, the observer is going to experience a different frequency of that wave. Also, it could be that the observer is moving towards or away. So it's all about relative motion of observer and the wave emitter. If they are moving towards one another relatively, essentially what happens is that wave gets sort of smushed up between maybe an ambulance over here emitting a sound and an observer standing right here. The wave gets smushed up, making the wavelength smaller and the frequency higher, and you actually hear a higher note. In terms of light, the wavelength would then associate to a different color that you might observe. Now, in the opposite effect, if a person is moving away from the sound emitter or a sound emitter is moving away from the person, then it's going to stretch that wave out and make the wavelength long and the frequency low, and therefore it would sound like a lower note, or the wavelength would get longer, and red waves are longer than this if we're talking about visible light. So Doppler effect is all about the idea of either smushing or stretching a wave based on relative motion of objects.